Hello, good evening friends. I hope you are following the thermodynamic video lectures. We have left over only small concept, that is the Carnot engine. So, we will discuss later. Meanwhile, we will start with solving the problems which we are already completed content. So, today our goal is to solve some of the problems. In that one, we are starting 2019 JEE mains problems. The problem is like this: a gas can taken from A to B via two different processes ACB and ADB. When path ACB is used, 60 joule of heat flow into the system and 30 joule of work is done by the system. If the path ADB is used, work done by the system is 10 joule. The heat flow into the system in path ADB question mark. There are the options 40 joule, 80 joule, 100 joule, 20 joule. Here is the indicator diagram is given ACB, ADB. This is the process. Now, this is the problem based on the two conditions. Point number 1, it is the first law of thermodynamic point, and also the sign convention rules we need to use, and also we should know the internal energy of the system. It is a path independent parameter. That two conditions we should know: the first law of thermodynamic, and also we should know the internal energy is a path independent function. So, then if you know this content, we are able to solve the problem. Let we solve the problem. What happened? Yes, some issue came, that is why I waited somewhat. So, now I am drawing indicator diagram one more time. Now, point A to B, this is the process. One is the process ACB and ADB. This is in the two ways it is going like this, and it is going like this way also. But one thing we need to understand, as the two processes are reaching point B, that is the same final point, the change in internal energy of the system at point B in the two cases must be same. That is the condition. That means the change in internal energy du in the case of ACB is equal to in the case of ADB, they must be equal. These two values must be equal. Now, we are going to use the first law of thermodynamics. What is the first law of thermodynamics? According to first law of thermodynamics. So, what it will tells? The amount of heat supplied to the system is equal to change in internal energy and external work done. So, as the sign convention, in the first case I am taking ACB case, the heat is flowing. See, in the path, when the path is followed in ACB, 60 joule of heat flowing into the system. That means when the heat is flowing into the system, that value must be a positive heat value plus dq. That means this is the value we need to take as the 60 joule positive, and 30 joule of work is done by the system. If the work is done by the system as per the sign convention, so this will be also positive, that is equal to dw is also positive, that value is equal to plus 30 joule. So, I am using these two values, that is equal to 60 joule of heat is supplied to the system, 60 joule of heat supplied to the system, dq we do not know, 30 joule of heat external work is done by the system. Now, I am sending this value to this side, then du is equal to, so in which case we are applying ACB condition we are applying, this case we are applying. So du is equal to 60 minus 30, that is equal to 30 joule. So then we can write it as the du and the according to the ACB path is equal to 30 joule. In this case we derived the value of internal energy at point B, but now I am applying the first law of thermodynamics in the path of ADB. So first law of thermodynamics, so I am writing TD thermodynamic. So in the path of say in path ADB, so that is equal to dq is equal to du plus dw. So we are following in the ADB rule. So how much heat is supplied, what is our condition, let me go, the heat flow into the system, that is our goal. So dq we need to find. So if the path is used, work done by the system, so this is the work done by the system means so this is also positive value 10 joule, we need to take it as the 10 joule. So then will you please understand here, so our goal is to find out the dq, du we do not know, that is equal to 10 joule we know, but this path is we are moving in the ADB according to the condition, what we know, as ACB and ADB they are moving in the same final point, then that is equal to du ADB value is equal to du ACB, both are same, that value just now we have evaluated, that is equal to 30 joule. Then in this equation I am writing that is equal to dq is equal to 30 joule plus 10 joule, that is equal to plus 40 joule. So this plus is indicating that what is the value, this plus is indicating that this much amount of heat required, this much amount of heat can be supplied to the system. So the 40 joule of heat is can be supplied into the system. Then what is the correct option? So A is the correct option, 40 joule amount of heat can be flow into the system in the path of ADB. So that is the answer. I hope you understand about this lecture. If you are feeling that these lectures are useful for your preparation, I am requesting you please subscribe to our channel for more videos. Thank you for listening. Thank you.